Sorting is one of the important problems in computer science. So first of all, let's try to understand what is sorting. Sorting is nothing but it's the process of arranging the given list of elements in an array in the order. That is, it is arranged in the ascending order or in the descending order. That is called as sorting. So let's try to define the problem of sorting. In the problem of sorting, you are given an input array. Let's say this is an array wherein the elements are 3, 2, 5, 1, 8, 6. The array that's given to you is unsorted. That is, it is not ordered, right? So your job is to apply the sorting algorithm. This is the algorithm that you're going to apply. By applying this algorithm, you should be able to get an array which is sorted either in ascending order or in the descending order. In this case, the output is ordered in the ascending order. We are going to learn about sorting in this lecture by applying this technique of sorting or this algorithm called as bubble sort algorithm. There are many other algorithms for performing sorting. There is quick sort, there is merge sort, there is heap sort, there is selection sort. There are better algorithms than bubble sort, but bubble sort is one of the simplest to understand. So let's start with this bubble sort algorithm. Let us take this array of size n equals to 5, and the index for this array starts from 0 and goes up to 4. Okay, this is the array that's given to you. Your job is to sort this array in ascending order. So finally the output should be 1, 2, 3, 4 and 5. This must be the output of this particular array after applying the sorting algorithm. Now let us take this array and try to sort it in the ascending order. So if you have to sort this array in ascending order, that means the element 5 should be residing at the very end, right? So 5 is the highest element, largest element, so that should come at the end of the array, right? So we will somehow try to bubble up or push up the largest element to the last index of this array. So if you can somehow push this element 5 to the index 4, our job is done. First of all, I'll catch hold of the number at index 0. So at index 0, I've got the number 5. And I can also catch hold of the number at the next index, that is index 1. So the next index, the number is 4. So I have these two numbers with me, 5 and 4. I have not seen any numbers in my array as of now. So what I do now is I'll compare 5 and 4. 5 is more than 4. So 5 should come after 4. So I'll have to perform swap. So I'll swap 5 and 4. So 4 comes to the place of 5 and 5 goes to the place of 4. So this becomes 4, 5 and 3, 2, 1. These numbers I have not seen as of now. Okay. Now one swap is done. Now I'll repeat the same process by comparing the element at index 1 and element at index 2. Okay, so there is 5 and 3. 5 is more than 3, so I need to swap their positions. So swapping is done. So the result becomes 4, 3, 5, 2, 1. This is how my array looks like as of now. Now I'll repeat the same process. I'll compare the element at index 2 and the element at index 3. So I compare 5 and 2. 5 and 2, swapping is required because 5 is more than 2. So now I'll swap the position of 5 and 2. So this becomes 4, 3, 2, 5 and 1. Now finally, I'll have to compare 5 and 1. Okay, so I see 5 is more than 1, so I need to do a swap there. So the answer becomes 4, 3, 2, 1, 5. Once this entire thing is done, see, I'm being able to push or bubble up 5 to its correct position. So I say that 5 is there at its correct position, or 5 is already sorted. Now all these elements are yet to be sorted. So now I'll repeat the same process one more time to make sure that I'll take the second largest number to its correct position. Now we will take this array one more time and we'll try to push up the second largest number, that is 4 in this case, to its correct position. So let's take this number in an array 4, 3, 2, 1, 5. Alright, 5 is already sorted. Okay, now first of all, I'll start with index 0 and index 1. So I'll compare 4 and 3. 4 is more than 3, so swapping is required. So this becomes 3, 4, 2, 1, 5. Okay, 5 being already sorted. Now I'll repeat the process. I'll compare 4 and 2. 4 is more than 2, so I need to bubble up. I'll need to shift 4. Okay, so the output becomes 3, 2, 4, 1, 5. I swapped 4 and 2. Okay, now I'll repeat the same process with 4 and 1. 4 is more than 1, so there is a swapping required. So this becomes 3, 2, 1, 4 and 5. Okay, now in this, if you see, 5 was already sorted. Now by doing this, all these comparisons, I have also placed 4 at its correct position. So now I say that 4 and 5 both are sorted, and these three numbers 3, 2, 1 are yet to be sorted. So I'll take this number 3 now. Okay, 3 and then 2, 1, 4, 5. Okay, so this is the array as of now. These two numbers are already sorted, so I need not touch these numbers as of now. Now first of all, I'll compare 3 and 2. 3 is more than 2, so swapping is required, so it becomes 2, 3, 1, 4, 5. Now I compare 3 and 1. Okay, 3 is more than 1, that is true. Okay, so swapping is required, so it becomes 2, 1, 3, 4, 5. Now if you see, we have also correctly placed 3 at its correct position, right? So we say 3 is sorted, 4 and 5 were already sorted. Okay, so now I'm left with these two numbers, 2 and 1. So now I take this array one more time, 2, 1, 3, 4, 5. Here 3, 4, 5 already being sorted. Okay, now I have these two numbers, 2 and 1. I compare them. Swapping is required. So now the output is 1, 2, 3, 4, 5. 3, 4, 5 were already sorted before. Now I have placed 2 at its correct position. Now in this case, if you see, I have already placed 5, 4, 3, 2 to its correct position. That means 1 is automatically sorted and placed at its correct position. If all other counterparts are at its correct position, that means 1 is also at the correct position. So I'm done. If you see, finally I get the output. This is the sorted array. Now the output is 1, 2, 3, 4, 5. We have sorted the array in the ascending order. If you observe closely here, we are repeating same process multiple times. So this box, this entire thing is called as pass 1. In pass 1, we bubbled up the largest element to its correct place. So 5 is placed here at index 4. Okay. And this is pass 2. Okay. In pass 2, what we did was we correctly placed 4 at its correct position. This is pass 3. In pass 3, what we did was we placed the number 3 at its correct position. And this is my final pass, pass 4, wherein we placed 2 at its correct position. In this example, we had number of elements n to be 5. So whenever n is 5, total number of passes that you are having is equals to 4. Now this is because each pass is responsible for placing the number to its correct position. So if there are 5 elements, if I can place 4 numbers correctly, the last number is automatically placed at its correct position, right? So therefore, we need 4 passes here. So if you have n number of elements, you will be needing n minus 1 number of passes. That means if you have 10 elements, you will be needing 9 passes, because by doing that, you will be placing 9 elements at its correct position. Okay, by doing 9 passes, and 10th element would be automatically placed at its correct position. So if you have n number of elements, you will be having n minus 1 passes, and in each pass we are doing comparison, right? We are doing comparison of adjacent elements. So if you see here I am comparing element at index 0 and index 1. Here I am comparing element at index 1 and index 2. Here I am comparing element at index 2 and index 3, right? So always I am comparing the element at index j and index j plus 1. Okay, this is what I am doing. I am comparing, and if my element at index j is more than the element at index j plus 1, I do the swapping. Like in this case, element at index 0 was 5 and element at index 1 was 4. So 5 is more than 4, so I do the swapping. If that is false, that means the element at index j is less than the element at index j plus 1, swapping is not required. So by performing comparison and swapping in each of these passes, and by taking care of these passes for 4 times, I was being able to sort these numbers. Okay. Now let us try to write down a function to perform bubble sort. Here the name of the function is bubble. It takes 2 arguments. The first argument is the array. Here the array is of type integer, and this array needs to be sorted. Okay, and n is the number of elements available in this array, and finally this code returns nothing, so return type is void. Now before we actually write down our function, let's try to look at this example, the same example that I have written down here. Okay, so we have already noted down that there are 4 passes. Now we need to give each pass a unique number. So let me call the first pass as I equals to 0. I'm starting from I equals to 0 because my array index starts from 0. I could have also very well started my pass index with I being 1. Okay, that is also alright, but I'm starting from 0 because my array index starts from 0, so it will be easier for me for performing the calculations. Pass 1 is indicated by I equals to 0, pass 2 by I equals to 1, pass 3 by I equals to 2, and pass 4 by I equals to 3. First of all, I'll write a loop here to take care of all my passes. There are 4 passes, so I'll start my loop starting from I equals to 0, indicating pass 1, and I'll go up to I less than 4. Okay, because I'll have to go up to 3. The last pass is I equals to 3, so I'll go less than 4. Less than 4 means up to 3, and I'll increment the value of I by 1. Okay, this is my loop. This will take care of all the passes. Whenever number of elements n equals to 5, I am going up to less than 4. Let's make it generic. So if I have n, I'll have to go up to less than n minus 1 by the same logic. So this should be written as less than n minus 1. This makes things more generic. So I'll write I is less than n minus 1. In this example, n was 5. So this will go up to less than 5 minus 1. That means less than 4. Less than 4 means up to 3. So up to index I equals to 3, indicating my last pass. Okay. So this is a loop that will take care of each pass. So whenever I am in I equals to 0, I am at pass 1. Okay. So this is my outer loop. Now once I am inside each pass, okay, let's say I am at pass I equals to 0, that is pass 1, I'll have to do the comparison and swapping if required. Okay. Now let's note down how many comparisons I am doing in pass 1. In pass 1, I am doing 1, 2, 3, 4 comparisons. I am doing 4 comparisons in pass 1. I am doing 3 comparisons in pass 2. I am doing 2 comparisons in pass 3, and I'm just doing 1 comparison in my last pass. Okay. So number of comparison in each pass is a variable. So now let's try to find out the relationship between the pass number and number of comparison. Okay. Let I denote the pass number and j denote the total number of comparisons, right? At pass 1, I equals to 0, pass number is 0, total number of comparison is 4. At pass 2, I equals to 1, okay, and total number of comparison is 3. Similarly, in pass 3, I equals to 2 and total number of comparison is 2. And finally, in the last pass, that is pass number I equals to 3, that is pass 4, total number of comparison is 1. If you observe here, I find I plus j to be equals to 4, right? So if you see, 3 plus 1 is 4, 2 plus 2 is 4, and 0 plus 4 is 4. So from this, I can find out j is total number of comparison in each pass is equals to 4 minus I. So I'll make 4 minus I number of comparisons in each pass. Okay. So if I'm in pass number I equals to 2, I'll make 4 minus 2, that is 2 comparisons. Okay. So for I equals to 2, I'll be making 2 comparisons as shown here. Okay. Now to be able to write down our loop to take care of all the comparisons in a particular pass, let's take this example wherein we have I equals to 1, that is we are talking about pass number 2, we are at I equals to 1. Okay. So whenever I equals to 1, total number of comparisons that you need to perform in that pass is nothing but 4 minus I, that is 4 minus 1. 4 minus 1 is equals to 3. So I have to make total number of 3 comparisons in that particular pass, that is pass I equals to 1, that is pass number 2. Okay. Now in pass number 2, if you see, first of all, I'm comparing the element at index 0 and index 1. So I'm comparing the element at index 0 and index 1, and then I'm comparing the element at index 1 and index 2, and then I'm comparing the element at index 2 and index 3. Now in this case, if I somehow know this starting index, I'll be able to find out the ending index. If I know 0, it is very easy for me to find out this 1, because 0 plus 1 is 1, because I'm comparing between the corresponding elements, right? So if I know the index 2, it is very easy for me to find index 3, because 2 plus 1 is 3. Similarly, 1 plus 1 is 2. Okay. So I'm concerned about finding these 3 indexes, right? So let that index denoted by j. So j should be 0, 1 and 2. So I'm actually counting for 3 times, but I'm counting starting from 0 because my array index starts from 0. So I have to run a loop here for j loop. J should be equals to 0. And j should be less than, it should be less than 3. That means it should be less than 4 minus I. It should be less than 4 minus I and then j plus plus. Okay. This loop will help me to run j starting from 0 to 2. So whenever j is 0, I am doing the comparison between a0 and a1. That means I am comparing between element at index j, that is aj, with the element at index j plus 1, that is aj plus 1. Okay. So this is what I perform in this loop. Now let us try to make this inner loop more generic, because here we are writing 4, right? 4 does not make it generic. I need to replace this 4 by n. Whenever n is 5, okay, this becomes 4. So 4 is nothing but n minus 1, 5 minus 1. So instead of 4, I need to write n minus 1. So this becomes j is less than n minus 1 minus I. Okay. N minus 1 in place of 4. Okay. I'm making it generic. Now this is how I run my inner loop. Okay. Now what I do is I need to compare between the element at index j and the element at index j plus 1. Okay, so I'll do the comparison. I'll check if the element at index j is more than the element at index j plus 1. I need to swap the element aj and aj plus 1. Now to swap these two numbers, it's very simple. First of all, I'll store the element at jth index in a temporary variable. So I'll have this temporary variable wherein I'll be storing the element at aj. Now as I've already copied the content of aj in temp, so I can store the element at index j plus 1 to aj. So I'll write aj equals to aj plus 1. And now I'll copy in aj plus 1 the temporary variable, right? So temp. So these three lines will swap the value of aj and aj plus 1. Okay, so once this entire thing runs in a loop, it should be able to produce our output of sorted array. In this function, I'll also be needing some of the variables that I have not declared. So I'll have to declare the variable I and j for running my loop, and I'll be needing one more variable temp for performing this swap operation. Okay, so this is the function for performing bubble sort. Now the code that we have written down for performing bubble sort is okay, it works fine, but it is not fully optimized. Okay, now let's try to understand this by taking this example. Let's say I'm having this array which is almost sorted. The elements are 1, 2, 3, 5, 4, right? So in the first pass, I'm just performing one swap here between 4 and 5. So finally I get 5 at its correct position, right? And in pass 2, you see I'm performing no swaps, although I'm comparing all the numbers, right? Because my algorithm says that I need to compare all these numbers, but no swap is performed in pass 2. There's no swap performed in pass 3, and even there's no swap performed in pass 4. Now once I know that there is no swap done here in pass 2, I did not actually go further, because in pass 2 there is no swap performed. That means the elements are already sorted, right? That means I did not perform pass 3 and pass 4. That will save my time. So let's try to place this here as a code. Okay, so first of all, let's have a variable called as swapped. Okay, so swapped is a variable that will take care if I've done any swapping, right? So swapped is initially 0. That means I have not done any swapping. Okay, starting with swapped 0, I get into the inner loop. Okay, I'll go into the pass 1, that is I equals to 0. In I equals to 0, there is a swap done. So whenever swapping happens, it gets into the if part. Okay, so here I'll just change the value of the swapped to 1. So whenever swapped is 1, I'm considering that swapping was done. Whenever swapped is 0, I'm assuming that no swapping was done. So in the pass 1, swapped is 1, so swapping was done, it's okay. So now it will go into the pass 2. When it gets into the pass 2, it will encounter this statement swapped 0. So swapped will be made 0 as of now. So swapped is 0. It will get into the pass 2. It will perform pass 2. In pass 2, there is no swapping done. So this will not be encountered in pass 2. So this statement if is not encountered. So swapped is still 0. Right? So once you come out of this pass 2, you reach here. Right? Now you check here if my swapped is still 0. That means no swapping was done. Swapped is still 0. Swapped equals to 0. Then I'll simply write break. Okay, that means it will come out of the outer loop. So it will come out of this outer loop, and then the program ends. So by introducing this variable swapped, we were able to optimize this code, right? We did not actually perform this pass 3 and pass 4, right? So we have saved a lot of comparison time. So therefore we have improved the runtime of bubble sort. It works faster now. Okay, so this is the optimized code for bubble sort. So that's all in this lecture. In this lecture we have learned about sorting problem. We have learned about bubble sort, how it works. We have demonstrated bubble sort by taking an example, and then we have devised our own function to implement bubble sort, and then finally we have modified our code to improvise bubble sort algorithm. That's all in this lecture. Stay tuned.